talk about how to graph a tangent function, the final of the basic trig graphs that we'll talk about, and the very, very similar to each other. They had the same type of shape, it's just shifted over a little than from what we had on the sine graph. A tangent curve looks completely different, but our goals are going to be the same as with the other two. We want to be able to identify the period and the amplitude of a given tangent graph or equation. We want to be able to write the equation and graph a tangent curve by hand when we're given its characteristics. So just like before, we need to first take a look at our parent function. So our tangent curve parent function is y equals the tangent of x. And again, remember that we are basing all of this off of points that we would get off of the unit circle. And on the unit circle, remember that tangent is sine divided by the cosine. So if we look at our quadrantals, which have these coordinates here, sine divided by cosine is y divided by x. So 0 divided by 1 is 0. 1 divided by 0 is undefined. 0 divided by -1 is 0. And 1 divided by, or -1 divided by 0 is also undefined. So what happens here as we make our graph is that it starts at 0, 0, and this didn't come out for some reason. 0 divided by 1 is 0. It starts at 0, 0, and the tangent is going to get bigger as we go up from 0, because obviously the tangent value is positive in quadrant 1. So it gets bigger, and then all of a sudden, at pi over 2 here, it becomes undefined. And what undefined means when we're looking at a graph is that there has to be an asymptote. So if I'm going to draw a graph here, here's pi. This would be pi over 2. At pi over 2, there has to be an asymptote because it has to become undefined. Then, because the tangent is negative over here, so what's going to happen is the tangent's going to gradually get bigger and bigger and bigger until it becomes undefined. Then, in quadrant 2 over here, it is negative and slowly gets less and less negative until it gets back to 0 over here at pi. So it's negative, it's negative, it's negative, it's negative until it gets back to 0 at pi. So because it's undefined here, we have the asymptote that goes that way. Then on the other side, as we continue into quadrant 3, if we look at the all scholars take calculus, it's positive again down here in quadrant 3. So that means that from pi to the next part, it would get bigger again. So, and then it would become undefined again at 3 pi over 2. Now, we're graphing more than a full period here just because I want to show you what the shape does. Now, on the negative side, it's going to be the same thing. If I extend this graph out to 2 pi, again, it comes back to at 2 pi, so it looks like this. But that's more than one full period because it goes up, it's down, and it's back to its starting point. So the period of this graph is pi. And you'll see that on the other side, if I do pi over 2 here, on the negative side, and then negative pi, it does the exact same thing over on this side. So down to the asymptote, and then on this side, it goes up. So again, I've graphed way more than a full period here, because a full period just includes the up, the down, and the zero. So we could have our period from negative pi over 2 to positive pi over 2. That would be 1. Or from 0 to pi, or from 0 to negative pi. That's all one full period. Now, on our other functions, the domain was all real numbers. Here, it's the range that is all real numbers. You can see that the y values are going on forever. The domain, instead of being squished between two numbers, like it was for sine and cosine, where it was between -1 and +1, here the domain is everything except where there's a vertical asymptote, because it's undefined every time there's a vertical asymptote, but everywhere else there is a value for x. So that means we're going to do all reals except, because it's everywhere except the asymptotes. So now we need to describe the location of the asymptotes. So we do that the same way as we did the others. We start with the first time there's an asymptote, so pi over 2, and then plus. On the other ones we did plus 2 pi n, because 2 pi was the period. Here it repeats every pi, because that's the period, so it's going to be plus pi n. The amplitude, this is easiest part of our learning goal. Identifying the amplitude on a tangent function, there is none. Amplitude doesn't exist because it goes on forever in both directions. The max value is infinity, the minimum value is negative infinity. The vertical asymptotes are, as we already discussed, starting at pi over 2 and repeating every pi. So that is our parent function, and again, we've graphed way more than a full period. You only need to graph a full period each time if you so desire. I usually graph a little more just because I want to see the shape. So find the amplitude and period of y equals 1/3 tangent of x over 4. So the period is going to be pi divided by b. Notice not 2 pi divided by b, it's pi divided by b. So amplitude is the easiest question. There is none. The period is going to be pi divided by b, which b here is the number in front of the x, which is 1/4. So pi divided by 1/4, which is pi times 4 over 1, which is 4 pi. So the period's 4 pi, there is no amplitude. And that's our answer to example 1. Example 2, state the amplitude and period and then graph the function. So again, amplitude is the easiest question. It's none. The period here is going to be pi divided by b. So in this case, b is pi. We've never had this happen before, which is why I picked it. Here, because my b value has a pi, the pi's actually cancel each other out. So that means my period is 1. So that means that I'm just going to graph a period on each side to try to keep it the way we've done the other graphs instead of the way I did the parent function above. So if I just want to do one period on each side, on this I only need 2 marks. So 1, and this would be my halfway mark. Then same thing on the other side. There is no amplitude, so I don't need to label the y-axis, but halfway to the period there's going to be a vertical asymptote. It starts at 0, it gets bigger, then small, and goes back to 0. So there's one period. Then on the other side, this one is negative, and it's back at 0 at -1, and that one is positive. So there we've graphed 2 full cycles of a tangent graph there. All right, let's try another graph. Again, notice I did the same thing here. So the amplitude, again, is none. The period is going to be pi divided by b, which is 4 pi. So the pi's cancel. The period is 1/4. So that means that's what I need to get to on my ends is 1/4 and negative 1/4. Again, on the tangent graph, you only need 2 marks. Half of 1/4 is 1/8. So those are our halfway marks. No marks needed on the y-axis. Vertical asymptotes go with the halfways. Starts at 0, goes up. This side goes down. This side goes down. This side goes up. And there we have our graph. All right, last part, being able to write the equation when we're given the information. And again, on the worksheet, you'll have somewhere you have to glean this information from looking at the graph. So make sure you know what a full period looks like. We have 2 full periods when we graph it here, the up and then the down on the other side. All right, so here, A is 3, and the period is 5 pi. Notice I just said what A is. I didn't say amplitude because there is no amplitude here. So if A is 3, that means it's just telling us that's what the number in front is. It's telling us the period so that we can find B. So pi over B equals the period, which is 5 pi. So if I want to solve for B, first multiply both sides by B. So pi equals 5 pi B. Then divide by 5 pi. These cancel. And so you have 1/5 as your B. So that means if A is 3, I've got y equals 3 tangent. And since B is 1/5, it'll be 1/5 x, which is x over 5. There's my equation. All right. Last one. A is 9/2. The period is 5 pi over 4. So we put pi over B equals 5 pi over 4. And again, when it's a fraction on both sides, it's easiest to cross multiply. So 4 pi equals 5 pi. So divide by 5 pi. And B is 4/5. So B is 4/5, A is 9/2, so y equals 9/2 tangent 4/5 x, 4x over 5, and that would be our final answer. All right, that's it for today. Skadoosh.